Okay, I'm having a look at this review sheet on linear equations. So we start with a question that has solved. Now this is going to make a bit of sense when we get to question 3. So just reminding us of our solving rules. So we've got our plus 3 here. The opposite of adding 3 is to take away 3. So that becomes 2x is equal to negative 3. And then we're going to divide by 2. So we get negative 3 divided by 2, and that will give us negative 1.5 as our answer. Then we've got to get onto some sketching questions. So we're completing some tables to sketch these graphs on this side of the sheet. So we've got y equals 2x. That means whatever the x is, we're multiplying by 2. So in this case, x is negative 1. When we multiply by 2, we get negative 2. If we have 0, 2 times 0 is 0. When x is 1, 2 times 1 is 2. When x is 2, 2 times 2 is 4. And then we can plot those points. So we've got negative 1, negative 2, the 0, 0, 1, 2, and 2, 4. And then I'll join those points with a line. I'll put my arrows on my end to show that that line continues going. And then I'll write the equation of the line on there. So that's y equals 2x. Then I'm going to do the next one. Now these are grouped together for a reason. So we've got y equals negative 2x. So whatever our x is, we're going to multiply by negative 2. So negative 1 times negative 2 is going to give us 2. Negative 2 times 0 is just 0. Negative 2 times 1 is negative 2. And negative 2 times 2 is negative 4. So we've got negative 1, 2. We've got 0, 0, 1, negative 2, and 2, negative 4. So what we can see, and I didn't bring my line down far enough there. So what we can see is we have now a straight line again, but this time our line has a negative gradient, so it's going down. We've got our y equals negative 2x. We can see that they both cross at 0, 0 because we don't have any y-intercept on the end there, so that's 0. And we can see every time, for the pink line, every time we go across 1, we go up 2, because it's got the gradient of 2. We can see that in our table as well, that our y values are going up in 2. Whereas in our negative 2x, we're going down 2 each time, and that line is going down 2 every time you go across 1. For part C and part D, we're going to graph these on the same one and have a look at the similarities there as well. So firstly, we've got our 2x plus 3. When x is negative 1, we're going to do 2 times negative 1 is negative 2, plus 3 is 1. 2 times 0 is 0, plus 3 is 3. 2 times 1 is 2, plus 3 is 5. 2 times 2 is 4, plus 3 is 7. So we can see that going up by 2 on that graph. And so we're going to plot those points. Negative 1, 1. We've got 0, 3. We've got 1, 5. And we have 2, 7. So we join them with a nice straight line, put our arrows on the end, write our name of the equation on there. And so we can see on that every time we go across 1, we're going up 2 because it has a gradient of 2. And we can see that it's crossing the y-axis at 3. Then when we do the next one, we've got negative x plus 3. That's the same as having negative 1 times x, and then we're adding 3 to it. So if we've got negative 1 times negative 1 is positive 1 plus 3 is 4. Then we have 0. Negative 1 times 0 is 0, plus 3 is 3. Negative 1 times 1 is negative 1, plus 3 is 2. And negative 1 times 2 is negative 2, plus 3 is 1. So we're going to plot those points on our graph. So we have negative 1, positive 4, 0, 3, 1, 2, and 2, 1. And there's our line there. So we can see that our gradient is not as steep. It's a shallower gradient because we've got a gradient of negative 1 rather than the 2 there. And we've got here that is crossing at 3 as well because we have that plus 3 that they have in common, so they have that same y-intercept. They both cross the y-axis at 3. On the next side of the sheet, we've got a question. Now we've actually got one of the same equations that we had on the front, but we're looking at it sketching a different way. So this time we want to sketch using our x and y intercepts. Now our y-intercept is when x equals 0. So we're going to write y equals 2x plus 3, but instead of x, we're going to write 2 times 0 plus 3. 2 times 0 is 0, 0 plus 3 is 3. So our y-intercept is at 0, 3. And we can pop that on our graph there. And then our x-intercept is when y equals 0. So we get 0 is equal to 2x plus 3. And this is just like that equation we had on the front. So we're taking away 3. And x is equal to negative 1.5. So we can pop that over here, negative 1.5. And then we can join that line together. And join those two coordinates. And we can see that just like on our page on the front, we had a coordinate of 2, 7. There's our 2, 7 there. We had the y-intercept of 3. We had the negative 1 there, and we had our 1 went up to 5. So same coordinates there, just a different way of graphing. Having a look at question 4, we're looking at our gradient and y-intercept from an equation. Now remembering that y is equal to mx plus c, where m is the gradient and c is the y-intercept. So we're just going to go through each of these and do the m and the c. So our gradient here is equal to 2. Our y-intercept is equal to 3. In B, we've got our gradient is equal to negative 3, whereas our y-intercept is equal to 5. In C, our gradient is equal to 1/2, and our y-intercept is equal to negative 4. So just be careful if you have a negative with your y-intercept that you don't forget that. Over here, we've got a gradient of 3. Now, we don't have any plus or minus on the end, which means our c is equal to 0. The y-intercept will be at 0, 0. And then here we've got a little bit of a tricky one. We've got y equals 5. So our gradient is going to be 0 because we've got no x in our equation, but our c is going to equal 5. Now the last one we've got here is looking at these lines and finding the gradient and the y-intercepts of them. So looking at A first, here's our A line. So what can we see about A? We're trying to get the gradient and the y-intercept. So straight away we can see the y-intercept is equal to negative 3 because it's crossing there. Now our gradient, a few ways that we can do that. We can draw our little right angle triangle in on the graph, and we can see that as we go across 1, it is going up 2. So that means its gradient will be equal to 2. Then for B, we've got our line coming down there. So we can see that it's crossing at 1. So we can see our C is equal to 1. And our gradient, so we're looking for 2 points on the line that are easy to work out. So we've got the 1 there and the 2 there. So the 0, 1 and the 2, 0. So as we go across 2, it is going down 1. So our gradient is going to equal negative 1 over 2. Then lastly, we've got this horizontal line here. Now with a horizontal line, we know that our gradient is going to equal 0. We can also see that it's crossing at 2. Now we could then come up with some equations for those lines using our y equals mx plus c. So here we would have y equals 2x take away 3. Then we've got here, we would have y equals negative 1/2 x plus 1. And this last one, we would have y is equal to 2 because we don't have that. We've got the 0 gradient, which means we won't have the x part of that because 0 times x is just 0. And that's finishing off that review sheet.